Imagine if, right at the peak of the Cold War space race, a relatively new engineering firm just dropped the complete, highly classified blueprints for a next-generation rocket engine onto the public internet.
Right, just totally free for anyone to download.
Exactly. Free to download, free to reverse engineer, free to build in your own backyard. You'd have absolute chaos in the aerospace industry. Well, today is July 27, 2026. And, in the artificial intelligence sector, that exact scenario basically just played out. We are looking at some massive breaking news.
It's a monumental day.
It really is. Moonshot AI, which is this ambitious startup backed by Alibaba, just dropped the full open weights for Kimi K3. I mean, we're talking about a 2.8 trillion parameter model here, and they released it under a highly permissive Apache 2.0 license.
The sheer scale of what happened today it's just hard to overstate.
Yeah.
But the true value of this release isn't really the shock factor, or the hype surrounding that massive parameter count.
Right.
The ground-shifting reality here is that developers can now run a model of this unprecedented scale locally, but entirely on their own infrastructure.
Yeah.
We are witnessing this definitive blurring of the line between the capabilities of closed proprietary models and open weight models.
Okay, let's unpack this, because seeing a frontier model become truly open source is thrilling, but it's also incredibly dense.
Yeah, very dense.
So our mission for this deep dive is to bypass all that hype. We are going to break down the actual technical architecture behind Kimi K3, explore the economic shockwaves it's sending through the industry, and most importantly, figure out what this means for your projects and your tech stack over the next year.
Absolutely.
But before we get into its capabilities, we have to clear up a massive technical misunderstanding that's dominating the headlines right now about what was actually released.
Yeah, that 2.8 trillion number is throwing a lot of people off.
It sounds so intimidating.
It does. And to understand why it's misleading, you kind of have to look at the timeline of the past couple of weeks. So Moonshot AI initially announced Kimi K3 at the World Artificial Intelligence Conference in Shanghai on July 16.
Right, just a couple weeks ago.
Yeah, and they opened it up through their consumer app and their API. But just 3 days later, by July 19th, the consumer demand was so overwhelmingly intense that Moonshot had to halt new subscriptions entirely.
Oh, wow.
Yeah, their GPU clusters simply maxed out trying to serve the public.
Which just proves people were genuinely flooding the gates to use it for real work, not just kicking the tires on a tech demo.
Exactly. So then they promised to release the open weights before the end of the month, which they fulfilled today by dropping the files on Hugging Face. But here's the catch with the headlines. 2.8 trillion parameters is the total size of the model on the hard drive. But it is highly misleading regarding how the model actually thinks and operates.
Right.
Because Kimi K3 utilizes a mixture of experts or MOE architecture.
When I was first trying to wrap my head around the MOE concept, the best way my brain could make sense of it was to think of a massive physical library.
Okay, I like that.
Right. So the model weighs 2.8 trillion parameters, meaning the library itself holds millions of books covering every topic imaginable. But when you ask it a question, it doesn't read every single book in the building to give you an answer. Out of 896 total experts or sections in this library, it only pulls out 16 specific books to read for any given word it generates.
That is actually a really highly accurate way to visualize it. Out of those 896 total experts, only 16 are actively firing per token.
That's a huge difference.
It is. So the actual computational power required to generate a response is a tiny fraction of that 2.8 trillion number. And that efficiency brings us to the reality of self-hosting this beast. The download itself is still massive. It's about 594 gigabytes.
Which is not fitting on your gaming laptop anytime soon.
No, definitely not. But the only reason it's even feasible for businesses to host is because of how Moonshot packaged it. The model is quantized in an MXFT4 format.
Right. I see that term thrown around a lot. What does MXFP4 actually do to a file that massive?
So it really comes down to microscopic data formats. Normally, AI weights, which are the mathematical connections that make the AI smart, they're stored in 16-bit floating point numbers.
High precision.
Very high precision. Downsizing to a 4-bit format, which is what MXFD4 does, is a bit like taking a massive, ultra-high-resolution photograph and reducing its color palette to just 16 colors.
Okay.
You drastically reduce the file size, but typically you ruin the image quality in the process. The standard industry practice has always been to train a massive model in high precision and then try to squish it down afterward to save space.
Right, post-training compression.
Yeah, and then post-training compression often causes the model to lose its reasoning capabilities.
So they compress it and essentially give the model temporary brain damage?
That is the risk.
Yeah.
But Moonshot bypassed that entirely by using what's called quantization-aware training.
Oh, meaning they knew beforehand.
Exactly. They didn't squish a massive model into a small box after the fact. They trained Kimi K3 from the ground up, knowing it would exist in a 4-bit world.
Wow.
The model learned to be brilliant within those constraints from day one. And this matters to anyone listening who manages infrastructure because it drastically reduces the memory requirements right out of the box without sacrificing the model's capabilities.
That is wild.
It really turns an unwieldy mathematical structure into something practical to load onto, enterprise-grade GPU clusters.
Well, if they manage to shrink the memory footprint, that effectively, it seems like that would free up a massive amount of computational breathing room.
It does.
So let's look at what that efficiency allows Kimi K3 to actually do under the hood, especially regarding its memory and autonomous tasks.
So the first major architectural leap taking advantage of that breathing room is Kimi Delta Attention, or KDA. To appreciate why KDA is so disruptive, you have to look at the bottleneck in traditional language models. They typically use something called quadratic attention.
Meaning as the text gets longer, the math gets exponentially harder.
Precisely, yeah, because of how it reads. In quadratic attention, every time the model processes a new word, it has to look back and mathematically compare that new word to every single word that came before it.
Oh, man.
Right, so if you feed it 10 words, it makes 100 connections. If you feed it 1,000 words, it makes 1,000,000 connections. It scales exponentially, and it becomes incredibly slow and expensive.
So KDA fixes that?
Yes, KDA replaces that bottleneck with a hybrid linear attention mechanism.
Wait, so how does linear attention fix the math problem?
So instead of comparing a new word to every past word individually, linear attention compresses all the past context into a single running summary. It's called a fixed-size state vector. Processing the 1,000th word takes the exact same amount of compute as processing the first word.
That sounds too good to be true. There has to be a catch.
There is. The trade-off is that pure linear attention tends to forget specific granular details from early in the text.
Right.
But Moonshot's hybrid approach uses exact quadratic attention for the most recent text to keep high detail and linear attention for the distant past. This fundamentally changes the math, allowing Kimi K3 to maintain an astonishing 1 million token context window without collapsing under its own computational weight.
Just to ground that 1 million token number for a second for you listening, you could feed this model a massive multi-repository code base, 10 years worth of a company's financial reports, and dozens of research papers all simultaneously, and it can process them in one prompt.
It's unbelievable.
But wait, if it's using that running summary for the distant past, how does it avoid losing the plot? If I ask it about page 1 when it's currently reading page 1,000, doesn't that information get diluted?
That is the exact vulnerability Moonshot addressed by introducing attention residuals, or ATNERIS.
Okay, what is that?
So in a deep neural network, information has to pass through dozens of layers of processing. By the time an input reaches layer 80, it can look like, a blurry photocopy of a photocopy.
Yeah, that makes sense.
Attention residuals essentially act as a bypass highway. They take the original high-fidelity input data and inject it directly into the deeper layers of the model, completely bypassing the local traffic.
Oh, wow.
It refreshes the model's memory, ensuring that crucial information flows deep into the architecture across those incredibly long sequences.
The architecture is clearly robust, but here's the feature that really jumped out of the data to me, the agent swarm.
Yes.
They inherited this from the previous K2.5 model. Most AI agents work sequentially, right? They search the web, they wait for a result, they read it, and then they write code based on it.
Right, step by step.
But Kimi K3 doesn't do that. It spins up multiple sub-agents to execute tasks in parallel. And the internal benchmarks show this reduces latency by up to 4.5 times in complex research tasks.
That's massive.
And as a cherry on top, it has native visual-to-code capabilities. You can literally show it a screenshot of a user interface, and it will just write the functional code for it.
It's an incredibly aggressive feature set for an open model, pushing past just text generation into actual, real, autonomous action.
Right, and here's where it gets really interesting, but wait. If it's spinning up all these parallel agents in a swarm to work simultaneously, doesn't that just create a massive liability?
How do you mean?
Well, if one agent hallucinates or makes a catastrophic logic error, and 3 other agents are building on top of that error in parallel, aren't you just making a bigger mess 4.5 times faster?
What's fascinating here is that your concern highlights exactly why the KDA and attention residuals we just discussed are non-negotiable for this model to actually work.
Oh, interesting.
The data shows Kimi K3 achieved a 2.5 times scaling efficiency improvement over its predecessor. That efficiency isn't just a speed metric, it's a coherence metric. Because every single subagent in the swarm shares that flawless 1 million token context window. They're all looking at the exact same master blueprint.
Ah, I see.
They don't drift off topic because the attention residuals keep the core objective front and center for every single agent. Think about what this means for real-world productivity.
Yeah.
When you combine a massive memory with parallel execution and visual-to-code, you are looking at a fundamental evolution in workflow automation. You are moving from an AI acting as a simple chat assistant to an AI operating as a coordinated, autonomous project team.
And I mean, if a local model can operate like a coordinated project team, that fundamentally breaks the current business logic of the AI industry. Architecture and speed are fascinating for the engineers, sure. But the reason this release is causing actual panic in the boardrooms of closed-source labs comes down to cold, hard math.
The economics, absolutely.
Let's look at the cost versus performance realities.
The benchmarks paint a very clear picture here, especially when you strip away the marketing fluff. Independent evaluations rank Kimi K3 second overall on Val's AI.
Okay.
On the front-end code arena, it actually claims the #1 spot. However, on the Artificial Analysis Intelligence Index, it sits in 3rd place overall, trailing just behind Claude Fable 5 and GPT 5.6 Solmax.
Right, and let's be totally transparent about those numbers. The data clearly shows Kimi K3 isn't the single most intelligent model on the planet right now.
Oh, it's not.
The top-tier closed models still retain a slight edge in absolute raw reasoning, but it is currently the most capable open model available by a wide margin.
And that slight reasoning edge the closed models possess, it comes at an astronomical premium.
Oh, yeah.
The economic disruption here is stark. If we look at the specific coding tests run by evaluators, completing a complex coding task on Kimi K3 costs roughly $4.65 in compute.
Okay, $4 and change.
Right. Running that exact same comparable task on Claude Fable 5 costs $13.41.
Wow. So what does this all mean for the listener? In a larger 452-task test suite, running Kimi K3 cost approximately $2,103. The closed alternative cost over $6,010. You are getting nearly 2.8 times more tasks completed per dollar spent. I mean, if you're a startup or an enterprise trying to integrate AI across thousands of employees, you can essentially deploy a team of senior AI developers for the computing cost of an intern.
Exactly. And if we connect this to the bigger picture, the battleground for artificial intelligence has officially shifted today. For the past 3 years, the industry obsession has been entirely focused on raw intelligence. The race to build the smartest, most godlike oracle, regardless of the cost.
Yeah.
Today, the race is about cost efficiency and deployment at scale. If a business leader can get near-frontier performance for a third of the price, plus they gain total data sovereignty because they can self-host the open weights on their own servers, the premium subscription models of closed labs face an existential threat.
It's true.
Why rent a slightly smarter brain for a massive monthly fee when you can own a brilliant brain outright for a fraction of the operating cost?
It's the multi-billion-dollar question that every CIO is asking right now. And the market isn't waiting around to figure it out either. Token usage data indicates that Chinese-developed models now account for roughly 60% of U.S. token usage on routing platforms like OpenRouter.
60%? That's crazy.
People are voting with their wallets. On day one of this release, infrastructure platforms like Together AI and Modal already had Kimi K3 hosted and ready for developers.
They moved fast.
There are even credible rumors circulating that Microsoft is actively evaluating Kimi K3 for their back-end Copilot workloads just to reduce costs.
The fact that American developers and major tech giants are so eagerly adopting a Chinese-developed model Brings us to the massive, unavoidable tension shadowing this entire release.
The geopolitical AI chessboard.
Exactly.
The momentum happening outside the US is staggering right now. To contextualize the scale of Kimi K3, it is 75% larger than the most advanced model DeepSeek had released up to this point.
Which is saying something.
Right. And the pipeline is packed. Alibaba is reportedly preparing to drop Qwen 3.8, which is expected to be a 2.4 trillion parameter model. Meanwhile, DeepSeek V4 is leaving its preview phase any day now. Industry analysts are already comparing this rapid, overwhelming succession of powerful open releases to the original DeepSeek moment of January 2025.
Yeah, but the difference is that January 2025 was a shock to the system. This is a sustained, calculated wave.
Yeah.
And this relentless momentum has brought intense scrutiny regarding exactly how these models are achieving frontier status so quickly and cheaply. In February of this year, 2026, Anthropic formally filed accusations against 3 Chinese AI labs, claiming they were training their models by distilling outputs from American models.
Distillation is a massive flashpoint right now. And just for context for you listening, distillation basically means taking the brilliant, nuanced answers generated by a massive, expensive model like a GPT or a Claude and using those answers to train a new, smaller model. Right. It's basically like a younger student copying the homework of the smartest kid in class to pass the test without doing the underlying studying.
It's important to look at this impartially, though. While the accusations against the Chinese labs highlight the competitive friction, analysts also point out that distillation is not a geographically isolated tactic.
Right.
It is a matter of public record that U.S. labs have publicly admitted to using various distillation techniques on their competitors' models as well.
Oh, definitely.
It is a highly controversial practice occurring across the entire global board as labs scramble to either catch up to the leader or drastically cut their own training costs.
And it feeds directly into the regulatory friction happening in Washington right now. I mean, there is a heated debate over national security versus market innovation. Should the government restrict the use of open Chinese models by American companies to protect domestic labs, or allow the market to compete freely to drive down costs for American businesses?
It's a tough spot.
But, setting the politics aside, I have a purely mechanical question about Moonshot's strategy here. How long can a company realistically spend hundreds of millions of dollars on compute clusters and top-tier talent, only to turn around and give away a 594-gigabyte state-of-the-art model for free?
This raises an important question that investors all across the valley are trying to answer right now. The consensus among market analysts is that releasing open weights at this scale isn't a short-term marketing stunt.
Okay.
It is a deliberate, aggressive strategy of commoditization. By continuously flooding the market with open models that perform at frontier levels, Moonshot and others force competitors like Google, OpenAI, and Anthropic into incredibly defensive positions. They are effectively reducing the value of the exact product U.S. labs are trying to sell at a premium.
Wow.
Even if Moonshot's long-term enterprise monetization strategy isn't fully crystallized yet, their current maneuver is successfully kneecapping the revenue models of their biggest closed-source competitors.
It's a high-stakes game of chicken played with trillions of parameters and billions of dollars. So, to wrap up our core mission for today's dive, the release of Kimi K3 proves without a doubt that the gap between open and closed models is not just shrinking, it's vanishing.
It's basically gone.
For you listening, especially if you're the one making technical architecture decisions or managing a department budget, the guiding question has fundamentally evolved. It is no longer just who scores the absolute highest on a logic benchmark, but rather who gives me the best return on investment, the most data privacy, and the most control for my specific use case.
The era of defaulting to the highest subscription fee for the best results is over. It is being replaced by an ecosystem of open weights that you can deploy and manipulate entirely on your own terms.
And I want to leave you with a final provocative thought to mull over, building on the specific technical realities we've just laid out. Combine Kimi K3's capabilities in your mind. It operates at a radically low cost. It has that 1 million token agent swarm capable of flawless parallel execution, and it has native visual-to-code abilities.
Right.
If a localized model can flawlessly look at a rough wireframe you drew on a whiteboard, understand your business intent, spin up a swarm of agents to write the back-end database and the front-end CSS for pennies in a matter of seconds. Perhaps the real disruption here isn't just about developers saving budget money.
Where are you going with this?
Maybe we are approaching the death of traditional user interfaces entirely. In the near future, you might not log in and click static buttons on a SaaS platform like Salesforce or Jira. You might just show a local model, a drawing of what you want to accomplish right now, and it will generate and execute bespoke, custom-built software in real time, just for you, allow you to solve your immediate problem, and then simply delete the software when you close the
Oh,
window.
wow. A completely ephemeral, custom-built digital environment generated on the fly for every individual task. It's a
Exactly.
profound implication of where this localized intelligence is heading.
We are moving from an industry that hoards classified blueprints to a world where you don't even need blueprints anymore because the machine builds the factory for you on demand. Keep questioning those underlying architectures, keep exploring how these cost shifts impact your industry, and keep a close eye on this open weight revolution. Catch you on the next deep dive.